And so really, I'll try to keep the slide portion of this relatively brief. But what Vantic is it is a platform for identifying situations of interest by orchestrating real-time events. You could say that Vantic sits at the intersection of streaming sources, other systems, and very specifically the individuals or people that have to interact with those streams to arrive at specific outcomes. In a business context, it's a business outcome. In a medical context, it's a patient outcome. In a military context, it's a mission outcome. And the whole goal is to give you the ability to effectively sense, analyze, and act on those situations of interest. I'm going to come back to this slide in just a moment, but what I want to talk about is sort of some of the underpinnings, some of the architectural decisions made in the platform to help you understand how it supports widely distributed, whether they're geographically distributed, decentralized environments with the ability to federate when necessary. So the first thing is to understand is that the Vantic platform is built entirely upon an event-driven framework. So it is built on an RX, or what you might call a reactive architecture. It is designed as an event-driven platform to separate messages from business logic, but as an asynchronous messaging platform, it is designed for the velocity, the variety, and the volume of real-time events and handling those events in real time that are necessary for mission-critical applications. The second thing that's really critical about the platform is that it has all of what I will call mission-critical attributes of applications built in. And those are, of course, the ilities of software applications, right? Reliability, availability, scalability, securability, and so forth. When you think about scalability, we traditionally think in terms of scale as horizontal and vertical scale. Vantic adds a third dimension of scale in that it is architecturally peer-to-peer based. This means that the runtime, whether you're running on we'll say Big Iron or something as small as a Raspberry Pi, is fundamentally the exact same runtime. They are architecturally peers. They all run autonomously. They do not need dial back to a master location or a central location. However, they do have the ability as peers to communicate with each other, to pass status along to one another, or pass parameters to each other with the right permission set and, of course, with the right connectivity. And what this means is that in those connected environments, you can run a remote command across the infrastructure. You could run a remote query across the infrastructure, of course, distributed messaging, and so forth. And then the last thing is that Vantic applications are collaborative, that humans are a critical aspect of the decision-making process. And you can think of it in terms of when a situation of interest is identified, something that typically represents an opportunity or a threat to an organization. Well, you've got to be able to capitalize on those opportunities or mitigate those threats. And in each instance, in asynchronous systems, since there's no predefined order, whoever the recipient of a current message is has to be able to take the next best real-time action. And that action may cause another downstream recipient to take a different action and so forth until you get closer or the best possible outcome, business outcome, mission outcome, patient outcome, et cetera, from those streams of data. And so that is what the Vantic platform is sort of encapsulated, or I should say the attributes that it encapsulates to support this idea of sensing, analyzing, and acting. And so I'll touch on these last 3 points for just a moment, and then we'll get into a live demonstration. When we talk about sensing, we're talking about the ability to bring data into the Vantic platform. This also applies to egress, so data can come into the platform. It doesn't just come into a black box. It can then be rerouted outside of the platform to other systems and other services. Out of the box, we support a number of popular protocols. We, of course, have our own built-in dynamic event broker. So we've got SDKs and REST APIs and WebSocket interfaces. But we'll also listen to the popular ones: MQTT, Kafka, AMQP, We have an enterprise connector framework that allow you to connect to other things, for example, UDP, TCP, etc. The point is that there's always a way to bring data into the platform, and it's highly customizable, as well as get data out of the platform. But then the question becomes, why do we bring data into the platform to begin with? And that is for the situational awareness. Once data arrives, it can be analyzed into those situations of interest, again, into those things that represent opportunities or threats. And we use these activity patterns, these patterns that you see on the left-hand side. These are the sort of no-code building blocks of building a real-time application where you drag and drop the various streams of data and the kinds of manipulation that you want to do to the data. So contextualization, enrichment, enhancement, aggregation, and things of that nature are all built in, and they all encapsulate those mission critical attributes. So everything that you build in Ventic automatically inherits those reliability, scalability, availability, and so forth. Once you've identified the situation of interest, however, it's not good enough to just simply send a message, there is an issue. Here is your issue. You have to be able to act upon that issue. And so we've also employed a special set of collaborative activity patterns that effectively allow you to do the first two things, to sense and analyze, but in context of a given problem. And this allows you to constantly monitor the stream of events in the situation at hand until you get to that best outcome that is possible from those streams of data. Ventic also includes a number of other capabilities. As I mentioned, it's federated. There's a number of development tools, not only for handling real-time streams of data, but also for building complex UIs and interactions, both web and mobile, and an entire operational environment that allows you to understand and monitor the environment, as well as perform tests and partition applications into pieces and deploy those to those individual locations. So I'll stop the presentation part of this here, and we'll jump into a demonstration. Jim or anyone else, if you have anything you want to add before I switch over to the demo portion.
No, please continue, sir.
All right, so I'm going to show an example of an application. This was modeled after one of our oil and gas customers. I think it'll give you a sense of the different kinds of real-time actions that we're able to take in. Some of these are sensor-based, some of these are historical-based, and the ability to seamlessly fuse streams of data together. The first thing that you're looking at on the screen here is an area monitoring the output of various well production. And the main goal of this is to simply monitor that the amount of oil produced is the amount of oil collected, and looking for any anomalies in that particular data. Other things that are really important that have to do with either safety or security are various kinds of perimeter checks and things of that nature. For example, one of the common things to look for is deterioration of the pipelines themselves. And so one of the things that will commonly happen in an automated fashion is requests to inspect specific parts. You can almost think of these as routines. And so what you'll see pop up in this issues section here in just a moment is that inspection request. And so an inspection request goes out at the same time I've received a mobile notification on my mobile phone. And so you can see there's been a dispatch request here on my mobile phone over here on the right, and you can see any information about where the location of that actually happens to be. Now, what this does is it sends out an automated request for a drone inspection of the various pipeline area. And so once the drone goes out, the drone is outfitted with a vision-based capability and 5G capability. So it not only does it know where it is, but it also has an engine on it that can identify specific kinds of situations of interest. In this particular case, it looks for things like dead vegetation, which would indicate an oil leak. And it will also look for things like overvegetation, which might indicate a water leak and potentially can damage pipes. So you've just seen on the screen a second notification has come in, which is the pipeline overgrowth alert. I'm going to click over here on the link here, and you'll see exactly what occurred, which is that the drone went out and started monitoring this particular section. So whether this happens to be monitoring the pipeline, but of course this could be monitoring security, this could be monitoring, doing surveillance on a particular perimeter or fence or otherwise. And what you'll see is that it's looking for those specific indicators. And so in just a moment here in the video, you'll see that it identifies either the dead vegetation or the pipeline overgrowth. In this case, you see the pipeline overgrowth being identified. Now, because the drone has GPS on it and it knows where it's seeing these specific things, when the drone identifies those, it also picks up the location. So when crews or personnel have to be dispatched to the area for investigation, it is marked in geo and 2D spherical location the explicit geo coordinates of those events. Now, of course, the crews can be monitored, their geolocations, or the soldiers deployed to a particular location, whatever that happens to be. Each of those things can be monitored in real time as the situation unfolds, as it progresses, and as you hopefully get closer to the ideal outcome of the mission or whatever it happens to be. The second thing that we'll take a look at is the actual facility itself. So here you can see this is now the refinery itself. And you can see there are a number of different kinds of sensors. So one thing that Vantic is particularly good at is this notion of doing something called sensor fusion, which is the ability to take different streams of data from different devices, different manufacturers, an entirely different suite of sensors, if you will, and combine them together for situational awareness. In other words, each one on its own may not mean anything, but their combined sensor input represents those situations of interest. For example, in this case, we have we've got about 10 different services being represented here. There's a local weather service, there's an actual on-the-ground environmental sensor doing wind speed and direction. You have leak detection here. This leak is not a liquid-based leak, this is pressurized gas leak. And so these sensors, these ones here that you see with this little acoustic symbol, these are acoustic sensors. They're looking for, again, pressurized gas leaks. And in this particular case, they listen at the ultrasonic level for the hiss, even an inaudible hiss to the human ear of a leak of some kind. That could be monetary in the form of, say, compressed air. It could be much more dangerous in the form of, say, methane gas or a particular kind of gas that might be more flammable. And so one of the things that becomes interesting is when you start to combine the different streams of data together. For example, if I combine the sensing of a specific kind of pressurized leak against wind speed, we can then make determinations as to how dangerous, even if it is methane, if it's in an outdoor area, as to whether or not that methane is likely to be dispersed much faster and be less dangerous, or if there's no wind speed, a much more volatile and much more dangerous situation. Fire, of course, is being detected from traditional sensing techniques, smoke detectors, heat-based detectors, but also in this case being detected by vision. And then you see this number of people jumping around here. And the reason this number is jumping around a bit is because these are the number of not only people based on either connectivity to Wi-Fi and hotspots, connectivity through mobile devices, but the number jumps around based on the number of people in front of cameras. So for example, if I click on this camera here, you'll see that there are a couple of people, once the video loads here, a couple of people in the camera's lens. Now, a few things that are worth pointing out. Yes, it is a video playing in a loop in the background, but the detections, the green detections, are not part of the video. So they are being laid on in real time as the system identifies those. And what Vantic is doing underneath the covers is taking each one of those inferences and converting it into 2D spherical coordinates. So this is really interesting because we have a camera with no specific GPS positional information. We have XY coordinates from these individuals, and we can take that and translate that into a location, a specific location on the map. So if you take a look at these three individuals, they're forming this sort of triangular shape, two gentlemen here in the front and one in the back. And if you look on the map here, as I zoom in, based on this camera's direction, we see those same two people in the front and one in the back. So it is mapping their location into physical coordinate space. This becomes incredibly important as it pertains to real-time situations of interest, because we'll need to know where these people are in the event that there's various kinds of evacuation criteria and so forth. So the next thing that we're going to take a look at is what happens when we start gaining or having situations of interest. What happens when the situation on the ground changes? So what you're going to see here in just a moment is you'll see, let me bring up my mobile phone, is you'll see that one of the leak detectors just went off. You can see which one it was. You also notice on my mobile phone, there's a pipe leak sensor that was triggered. So what the system has just done is one of our pieces of equipment here, specifically this piece of equipment, has gone into alarm state. It is now hearing the hiss of the pressurized gas leak. And what it's done is it's gone out and it's notified the right individual with the right skill set in the right georadius who can actually handle this specific issue. And it's gone ahead and it's sent them a notification on the mobile phone. So they are now prompted to investigate. They have a number of things that they can do. They can raise the alarm status. They can investigate. They can start triaging that situation of interest. Of course, these things don't necessarily stay static. Now, at the same time that this occurred, the system, as you know, sent out that mobile alert. And when it sent out the mobile alert, it was able to identify not only the individual who were responsible, but it was able to start a conversation. So one of the things Vantic is able to do is incorporate generative AI and not only allow people to interact with generative AI at a prompt level where a human can ask a question, but Vantic allows real-time streams of data to effectively make a facility or make a base or make a city come alive by initiating the conversation. If I kind of jump back to the mobile here, you can see that it started the conversation. This isn't starting with the human. Rather, the assistant said, a new issue was just identified at the date to 2023-11-14 at the Acme refinery. Appropriate personnel have been notified of a pressurized gas leak. Type of gas at this point in time is unknown. Well, I can also now start interacting with this. So I could say something like, how many people are at the facility? And by interacting with the situation or with the building, the building now has its own contextual awareness of what's going on at a given moment in time. And so the system will come back in a moment and it will report what it knows about the current situation on the ground. So we'll give that just a moment here. The other thing is, of course, the generative AI engine that you use can be faster or slower depending on where it is, whether it's on premises, whether it's in the cloud, and so forth. And so these kinds of interactions can be highly tailored and highly customized. At the same time, by the way, well, there it is. So it's come back. It says there are currently 29 people at the Acme refinery. At the same time, what if the situation evolves? What if things change? What if that gas then ignited and became a fire? So one of the things that you'll see, I'm going to go ahead and trigger the fire in this particular case, but you'll notice it doesn't then need the human to ask another question. The building, as I mentioned before, effectively has the ability to speak for itself. So I want to go ahead and click on this here. This will just basically simulate that fire condition. And if you look back on my mobile, you'll notice the mobile, the three dots have appeared. The building is already speaking back. So without the user sending a prompt back into the environment, the building is speaking back. So this allows a multi-way conversation as to what's going on. So this time it says the status of the ongoing issue has changed. There's an update. The new issue is a fire. There's a methane ignition. This was caused by methane gas. Appropriate personnel have been notified. And then it tells you the evacuation conditions. It says only individuals in Sector 1 should evacuate. Others should stay alert as the situation progresses. So it's basically pulling from a semantic index of understanding about what the criteria is for partial and full evacuation. How many people are near the fire? And so it's worth pointing out that adding this conversational element is all built in these low-code patterns as well. And so it was a matter of only a couple of hours of incorporating something like this into the environment. So here you can see it says there are currently 3 people near the fire at the Acme refinery facility. And so we can continue to evolve and monitor the situation. At the same time, other notifications have gone off. If you look at my notification list, there was the emergency evacuation alert that went to those individuals who were within the immediate vicinity on the map. And for those individuals who did not reply and get to safety, it sent emergency crews notification as to where their whereabouts are so that emergency crews would know where to effectively help people. Effectively, these 3 people are still in the environment. They have not left. And that's why the system continues to send out those notifications. This is what it means to be situationally aware and provide real-time context and understanding of those situations, as well as the ability to iterate until you get to the best possible business mission outcome, etc. And I think I'll wrap up the demonstration there. And of course, if you have any questions, please let me know.